Hi, this is the third video in the series where we've been looking at paper 3, and it's the specimen papers set 1 for Edexcel. In the previous question we finished at question number 10, so we're going to move on with question number 11. Like before, I'm going to aim for this video to be about 25-30 minutes in length. Please do stop and start the video, have a go at each of the questions and then compare your answers. Okay, so on to question number 11, which deals with something called completing the square, which is a technique that you need to be aware of, particularly if you're going to be studying at maths at higher level. So we do this quite frequently at higher level. Okay, so the first thing is that we've got this right x squared plus 2x in the form of x plus m squared plus n. Okay, so what we do, the technique is that we take the first two terms and then we write it as x plus 1. Okay, so we actually half that number 2 to become 1 and we square it. Okay, now if we look at that, what we actually end up with is x plus 1 times x plus 1. Okay, well if you work that out, what you end up with is x squared plus 2x plus 1. So in other words, we've got the first two terms, but the problem is we've got this plus 1 at the end. So what we would actually do is minus that 1, okay? And that means then that this is directly equivalent to the first two terms. Then we've got to deal with this third term, which is minus 8. So if I minus 8 from there, it's then just a case of tidying this up. So we end up with x plus 1 squared minus 1 minus 8 is minus 9. So in this particular case, we've got m is a value of 1 and n is a value of minus 9. So m equals 1 and n equals minus 9. Okay, hope that's all right for you. Let's move on then to question number 12. And question number 12 just deals with 3D Pythagoras. Now, a little bit tricky because half of the problem with these sorts of questions is actually just visualizing it properly and making sure that you can actually see what's going on. Okay, so in this particular case, I've got various measurements that it tells me. So it tells me AB, for instance, and AF and all that. So what I'm going to do is I'm actually going to put those into the diagram itself. So AB is 7, AF is going to be 5, and FC is going to be 15, which is this dotted line along here. And what we're being asked to do is work out the volume. Well, in order to work out the volume, what we need is, if I write out the formula for volume, so volume equals area times depth. And this is really important that you kind of write these formulas out if you can. So area is fairly straightforward because it's basically going to be this area along here, which is going to be 5 times 7. The problem we've got is we don't know the depth. We need to work out effectively BC. Okay, so let's have a look at that. So what I'm going to do is I'm going to use Pythagoras, and I'm going to use it a couple of different ways. The first thing is that I'm going to work out this length along here, because if I can work out that length, then it means I've got a 7 here. I've already worked this out, so if I've worked this out and I've got a 7 here, I can work out this length. Okay, so the first thing is I need to work out AC. It's this to this. Now, I suggest if you're not sure about how this is working, maybe get hold of just a box of some sort and try to kind of sketch this out on the box so you can see what it is we're trying to get to. Okay, so effectively I've got a right angle triangle with a height of 5, which is this height 5 AF, and then a hypotenuse length of 15, which is this length along here. Okay, so what I can do is I can say that this is AC, and AC squared equals 15 squared minus 5 squared. And if I pop that into my calculator and work that out, that's going to give me 200. So therefore AC, which is this dimension along here, or this dimension right along the bottom there, is going to be the root of 200. Now, if you want to, you can actually just calculate that because it's a calculator paper and work that out, and that's absolutely fine. However, I tend to leave it like that because I'm going to use this information to work out BC, because effectively now, and I'll just sort of draw a triangle again. It's going to be a little bit difficult to draw it flat, but I've got this triangle that looks like that. Now actually that's a right angle. It's actually this one along the bottom here. So this is 7. This is going to be what we're trying to work out, which is BC. And now what we're told is that AC, which is this length along here, we've worked out as the root of 200. Okay, so we now need to use that information to work out the value of BC. Okay, so let's do that. So we're going to say that BC squared equals 200. Don't forget that that's AC squared. Okay, so the actual value is 200, but the square of that is going to be 200, is root 200, and the square of that is going to be 200, and that's going to be minus 7 squared. Okay, so that's going to equal 200 take away 49, which is going to give me a dimension of BC, which is the root of 151. Okay, so now I can use that information back to my original formula, area times depth. Okay, so let's just have a look at that. My volume is going to be the area, which is 5 times 7, put that in brackets, and multiplied by the depth, which I've said is the root of 151. Okay, if I put that into a calculator, I'm going to get 430.0872. Now again, like a lot of these questions, please don't forget that they've asked you to give the answer correct to 3 significant figures. So the answer to 3 significant figures is that number there, 430. So the volume is going to be equal to 430 centimetres cubed. Okay, right, and that would be the answer to this particular question. Okay, hope that's all right for you. Let's move on then to question number 13. And question 13, okay, we've got 14 boys and 12 girls in the class, and work out the total number of ways in which 1 boy and 1 girl can be chosen. Okay, well that's fairly straightforward. It's 1 boy to 1 girl, so therefore it's going to be 14 times 12, which is 168. Okay, so there are in fact 168 ways in which the boys can be chosen with the girls. Okay, let's move on then to question number 14. And in question number 14, we've got a fairly long and detailed fraction that we need to work out, and it says write this horrible thing as a single fraction in its simplest form. Okay, well in here, firstly we're going to be dealing with whatever's in the brackets first, and also we've got the division side there, so it's going to be a little bit tricky to work through, but let's have a go at it and see where we work out. So I'm going to ignore the 4 outside, and I'm going to work totally within the brackets themselves. Okay, so let's have a look at how that works. Well, basically we've got then x plus 3 divided by that over that. So the first thing I'm going to do is I'm going to move this around the other way, because effectively we've got x plus 3, and that's, if you like, it's over 1, and that's going to be multiplied. Now, whenever we divide fractions, what we do is we multiply and flip them round the other way. So I've got x minus 2 divided by x squared plus 5x plus 6. Okay, so it's like dealing with any single fraction. Whenever you divide them, you need to multiply and flip them around the other way. Okay, so let's have a look then at how this is going to work out, particularly if I factorise this. Okay, so I end up with 4 minus big brackets, and I've got x plus 3 multiplied by x minus 2, so that's the top bit of it. And then at the bottom, what I need to do is I've got 1 times this, so that's absolutely fine. I'm just going to leave it like that, and I'm just going to factorise this. Now if I factorise this, I get x plus 3 multiplied by x plus 2. Now if you're not sure about how I've done that, please do have a look at factorising. It's just at this sort of level, then really it's important that you're able to be able to factorise these types of equations relatively straightforward. Okay, so what I'm going to do then is get rid of the x plus 3 and the x plus 3. And what I'm left with is 4 minus x minus 2 divided by x plus 2. Okay, so we're in a position then where we've got this situation where, again, it's dealing with fractions. So this time we've got minusing 2 fractions from each other. So what I need to do is make sure they've got the same denominator. So in this particular case, I need to make sure this 4 over 1, that 4 is the same as saying 4 over 1, has got a denominator of x plus 2. Well, the other way I'm going to do that is if I multiply top and bottom by x plus 2. So what I end up with is 4 times x plus 2 divided by 1 times x plus 2, and that's minus x minus 2 divided by x plus 2. So this second fraction doesn't actually change because it's already over a denominator of x plus 2. Okay, so then let's have a look at tidying that up a little bit. Well, if I multiply out these brackets, or this bracket here, what I end up with, I'm just going to take this up here a little bit, I'm going to end up with 4x plus 8 minus x. Now, be very careful here because this minus affects this as well. So this is minus x and minus minus 2, so it's x plus 2. And that's divided by x plus 2. So what I've done then is I've brought these two denominators together and just written it as one single fraction. So do be careful about these negatives. Every time you see those, always be ultra cautious. Okay, so if we type that up again, I've got 4x minus x is going to be 3x. And I've got plus 8 plus 2 is going to be plus 10, and that's over a denominator of x plus 2. And that's the answer to this particular question. Okay, I hope that's all right for you. Let's move on then to question number 15. And question number 15 deals with, effectively, it's actually looking at indices and dealing with indices. And what it says is a virus on a computer is causing errors, an antivirus program, blah, blah. An estimate for the number of errors at the end of t hours is 10 to the 6 times 2 times minus t. So t hours, okay, and it's asking us to work out 8 hours. So basically all we do is plug that information into the formula. So what we say is that's 10 to the 6, which is the first bit of the formula, times 2 to the minus 8. Okay, because all we've done is we said t hours. Okay, there's your t. Okay, plug in the number 8 and we get minus 8. Okay, and then if you plug that into a computer, into a calculator, you're going to end up with 3906.25. So the number of errors at the end of 8 hours, my gosh, is going to be 3,906. Okay, so then it asks part B, explain whether the number of errors on the computer ever reaches 0. Well, okay, to all intents and purposes it does, but what they mean is that effectively no it won't, because 2 to the power of minus t, so whatever that value of hours is always above 0. Okay, so you might just plug in a few numbers into your calculator and just have a look at that. But it means then that although it's always above 0, it will be 0 to the nearest number. Okay, so just have a look at some of those and satisfy yourself that that statement would be correct. Okay, so let's move on then to question number 16. Question number 16 deals with the transformations of graphs. Okay, and what it says is that the graph of y equals f to the x is transformed to give the graph of blah. Okay, so let's just have a look at that. What we're saying is that we've got a graph. Okay, and at some point on that graph we've got a function of some sort. I'm just guessing here, it doesn't really matter what it looks like, but a function of some sort of point of some sort, and it says there is a point on it which is a, and that point is 9, 1. And what they're asking is what happens to that point when the graph is transformed to this. Well, let's just not worry about that minus f at the moment. If we look at the brackets, if it's x plus 3, then what that happens is it moves along the x-axis in the negative direction. So actually what happens is that point will move 3 places along, so the graph will actually go like that, and that will become 6, 1. Okay, and that's the effect of this x plus 3. However, the other thing is that, or the other point is that it's reflected in the x-axis because of this minus. So what happens is that that point now, so you've got the graph here, is then reflected over here. So actually that becomes minus 6, 1. Okay, and actually that's the answers to the question. So although my drawing's absolutely awful there, you might have a look online and see. There's a program called Desmos that you might want to have a go at. It's a graphing calculator, and see if you can work that out for yourself. But basically the coordinate point P after this transformation is going to be minus 6 and 1. Okay, so I'm conscious of the time, it's 16 minutes in, so we're going to move on then to question number 17. Question number 17 deals with a solid cone. Okay, so we've got a solid cone, and it asks us to work out the value of V. Okay, so we've got a couple of things going on with this. What we need in order to work out V is a couple of bits of information. So the first thing I'm going to do is I'm going to look at, they've given us quite a lot of information here. Okay, and what this will allow us to do is to work out the value of x. Okay, so the way that would work out is we can say that we've got this cone where effectively it's like that as a cross section. Okay, and that gives us a height of 16x, and then it gives us a radius along here of 12x. So what I've done is I've just taken a triangle. If I sort of put that into here, a little triangle like that, okay, and then that allows me then to work out this value along here, which is the slant height, and I need that slant height. You remember that if I've got the curved surface area, it's L, which is the slant height along here, which I'm trying to get to. Okay, so what I end up with is saying that this length along here is going to be, if you like, L squared is equal to 16 squared plus 12 squared. Okay, that means that L equals 20x. Okay, so this is 20x. And if you just plug that into your calculator and then square root it, that plus that is going to be 400. Square root it, and that's going to give you 20. And I've said that that will be 20x along there. Okay, so we can use that bit of information then to work out the surface area. So the surface area is going to be, we're told it's 2160 pi, so that's 2160 pi, and that equals pi RL. So I'm actually using this information from the inset over here. The curved surface area of the cone is pi RL. Okay, so let's now plug all that information in, and it's going to allow us to work out the value of x, because it's 2160 pi. That equals pi, and then we've said the radius is going to be 12 x, and if I've put this decimal point or this little point in here, it just basically means multiply. Okay, I just think it's a little bit neater. And then L, which is the slant height, we've worked out as 20. Okay, so that's multiplied by 20x. Okay, now if you plug all of that together, what you're going to end up with is 12x, or 12 times 20 is going to be 240, and I can just cancel everything through really, because I'm going to end up with 2160 divided by, well, if you like, pi divided by 240 times pi. So those two are going to disappear, and that's going to give me x squared, because when I multiply those two together, I'm going to get x squared. So this bit is 240x squared. Okay, so I end up then with x squared values 2160 divided by 240, and again put that into a calculator, and you're going to end up with x, which is a value of 3, so x equals 3. All right, so I'm now in a position where I've got all the component parts I need to be able to work out my volume. Okay, so the volume, it says the volume of the cone is V pi centimeters cubed, where V is an integer. So what they're asking us to do is to work out the value of that integer, or the value of that whole number. So let's go back then to the formula sheet, and it says volume of the cone equals 1/3 pi r squared h. So volume equals 1/3 pi r squared h. Okay, so now we've got all the bits and pieces in place that we need. We can say we've got 1/3, that's multiplied by pi. Now the radius squared is going to be 12. Oh yeah, so okay, so the radius is now going to be basically 12 times 3, because we've worked out the value of 3 as being the value of x. So actually the radius is going to be, we said it was 12x, so it's now going to be 12 times 3, which is going to be 36. Okay, the height is going to be 16 times 3, so 16 times 3, and that's going to give us a height of 48. Okay, so we've worked out the value of x. We can use this information. Okay, if we go back to our original sketch, we've got this radius as being 12x, so 12 times x is going to be 36, and then the height is 16 times x, which is 16 times 3, which is going to be 48. Okay, so it allows me then to work out the volume. So here I've got 36 in place of r, so it's going to be 36 squared, and that's going to be multiplied by the height of 48. Okay, if I work all of that out, I end up with 20736 pi. Okay, so in this particular case, V equals 20736, which is the integer value that they talk about. Okay, quite tricky, that particular question. I'm sorry I lost my way a little bit, but hopefully you'll be able to catch up and have a look and see what I've been doing. I think at 23 minutes, I think we've just about got time for one more question. So I think we'll do one more question, see if we can get this through to about 30 minutes on, maybe one or two more questions. So let's have a look then at question number 18. So in question number 18, we've got this probability where Thelma spins a biased coin twice. The probability to come down heads both times is 0.09. Okay, so calculate the probability that it will come down tails both times. So just be a little bit careful. If it comes down heads both times, what we're saying is that heads times heads is equal to 0.09. Okay, so in other words, the square root of 0.09 is actually 0.3. Because 0.3 times 0.3, remember it's heads times heads, is 0.3 times 0.3 equals that. Okay, so therefore the probability of it landing on heads once is going to be 0.3, and once again is going to be 0.3. So therefore the probability for it landing on tails and tails is going to be 0.7 times 0.7, so that's going to be equal to 0.49. Okay, that's the answer to this particular question. Okay, let's move on then to question number 19. And at long last, we've actually got a question that's relatively straightforward. Okay, we're being asked to write this in standard form. So all we're going to do is just say that that would be 4.23. And we've moved the decimal point 1, 2, 3, 4 places to the -4. Remember, it's minus in that direction. Okay, and then we're going to write this as an ordinary number, so we're actually moving the decimal point 4 places, so it's 4.5, and we're going to move it 4 places, so once, twice, 3, 4 times, put a load of zeros in there just to keep the value, and that's going to be 45000. Okay, so hopefully that was all right for you, and it makes a bit of sense. Okay, so let's have a look at, I think what we'll do is we'll leave this here at 25 minutes because the next question is going to take a little bit of time. So I think we'll leave it at this particular point. I hope it's been useful for you. Please do add a comment below if you're not sure about anything. Subscribe to the site, and I'll look forward to seeing you inside the next video.